Hello everyone, I'm teacher Winnie. Today we will discuss on Physics SPM Trial 2024 Selangor paper set 1 for paper 2. So let's look at the first questions. First question is from Form 4 chapter 5 wave under the idea of interference of wave. Diagram 1 shows the interference pattern of water wave produced by two coherent sources S1 and S2 in a ripple tank. So firstly, what is the meaning of interference? So for your understanding, for interference of wave to occur, we need to have two sources which are at the same phase and same frequency, which is S1, S2, they have a two dipole, then they have to dip at the same time, the frequency must be the same. And what happened is the ripple that produced, right, they will have the overlapping part. So this overlapping part is the idea of interference. So the meaning of interference will be superpositions of two or more waves from a coherent wave source. Okay, so now what is meant by coherent source? Sources which have what? Same frequency and constant phase difference. So see, you are required to draw and label an antinode line and a nodal line. So for information, okay, if you look at sideway, right? So the water wave will look like somewhere like that, okay? The top part here is actually the idea of crest. Okay, whereby they're using the darker line, darker line. Then the one that lighter one, I use another color, easy for you to capture, okay, which is the bottom line, okay, but I do dotted. So this in between one is dotted, where they call it at trough. They call it at trough. Okay, so what happened is when you have the idea of crest overlapping with crest, you produce maximum amplitude, okay, or the idea of trough, overlapping trough, you will produce maximum amplitude as well. But if you have the idea of crest meet with trough, then what do you have? Your result idea is zero amplitude. So when you have maximum amplitude, this idea is called constructive interference. And those point is actually called node, antinode, okay, antinode. Whereas if you've got zero amplitude, then this is also called destructive interference. And the point is also called node point. So I always tell students, destructive means something that no good, no node. Okay, but anti-node means something that good, constructive. So they want you to label an anti-node line and nodal line. So let's find the anti-node one, constructive. So constructive, I will use a big dot to find the point. So how do you get this big dot? Is you see crest and crest means darker line intersect, or the lighter line, which is trough and trough. This is crest and crest, trough and trough, crest and crest. Okay, so you see, I join this line, then you label this line is actually called what? Anti-nodal line. The blue one is called anti-nodal line. So if I want to find the nodal line, I denote it with a cross. Okay, you see one darker and lighter line intersect, then there will be anti-nodal because crash and trough, crash and trough, crash and trough. Okay, so you can freehand, or if you worry a bit, you can use ruler lah, if they are not so curvy one. Okay, so I actually label both nodal line and anti-nodal line already. The green one is nodal line. Okay, of course there is more for you to draw it out. So these are other example. Okay, so you draw, see or not? So the red one is anti-nodal line, while the blue one is nodal line. Okay, so this is questions 1. So for questions 2 is from Form 5, electronic, on the topic of transistor. Okay, so as you know, transistor have two functions. One, act as current amplifier. Another one, they are act as automatic switch. So what is this Q, component Q refer to? Is actually light dependent resistor, or where you have double arrow. If you were to have a rectangular shape and then a slanting line with a straight line, this is thermistor. So these two are special type of resistor under the topic for automatic switch lah. Okay, so now we focus on this light dependent resistor. Okay, we see how it works. Okay, so what is the function of this light dependent resistor? Okay, so generally they will actually sensitive to light lah. When it is bright, the resistance of this resistor is basically low one. But if it is dark, low intensity lah, the resistance will be high. Okay, so the concept on this idea is, okay, for your information, to understand transistor, we didn't really study very thoroughly on the theory part or inside what happened to the depletion region, all this, okay, whereby you all learn in diode. Okay, so for transistor, okay, what you need to know is they have three legs. The one that on the center is called base, then you have collector without arrow one, and then emitter which is with arrow one. Okay, and they are special because they have three legs and they can actually form two or more circuit. So the circuit over BE, the leg for BE is also called base circuit. You need to know all this general idea. And then collector emitter is called collector circuit. And that's why current that flow in base circuit is called base current. Okay, and then collector circuit, this is called collector current. Okay, I use base circuit with the blue color. So this is some basic idea. Okay, so for the idea to work at automatic switch, we need to always know what happened at the base circuit. So the voltage across this resistor is also called base voltage, and the current I already mentioned is called base current. So we need to know what happened. So in short, okay, or basic idea is, whenever the base circuit, right, their voltage is high or resistance is high, automatically the voltage is high as well. And they will cause the base current to flow. The moment base current can flow, that means the transistor will be activated or is on. Okay, when they switch on, that means your collector current can flow. Okay, with a bigger current, and hence you can light up the bulb. Okay, so they ask what happened to the base voltage when dark. So like teacher say, during dark, resistance of LDR is high. If your resistance is high, okay, because voltage and resistance is directly proportional, also your base voltage is high. So base current will be high. That means the bulb will light up. The bulb will light up. So that's why it increases lah. Okay, they're asking about the voltage idea. Okay, so for C is the calculation. So to understand or remember or recall the formula for potential divider, right? It's not something that is hard. So it tells students, you see current flow from positive to negative. Generally, the current that flow through the first resistor upper part here and the second resistor bottom part here is actually same, okay? Because there seems to be arranged in series, right? The 20 kilo ohm and the LDR. So current is same. Okay, but what is different is the resistance and the voltage across it lah. The voltage across it. Okay, so to make it easier for you to capture the idea, I'll denote this top resistor as 1. This second one is 2, understand? Or you want to put Q also, doesn't matter. So the idea behind is, I always tell students you use the ratio, ratio. Okay, so the voltage here is V1, or this is V2. So they always want to find out what is the relationship between the top part resistor or bottom part resistor, which compare to the total voltage and total resistance idea for your information. Okay, so the concept itself, why these two resistors act as potential divider, because based on the idea of resistance, right, they will cause the voltage to be different, but the V1 plus V2 idea is always total voltage. Also, these are some basic that you all need to know. Okay, and then the total resistance, or in this context, is also R1 plus R2, and then current is the same. So to form the equation for potential divider, right, is not something that hard. I always tell students you use partly. Okay, V1 over R1 is generally they always use the R on top. Okay, R1 over V1 equals to my bad. Again, we use the idea of total or partly. So V1 over total V equals to R1 over total R1 plus R2. Okay, hence your V1 will be equals to what? R1 over total R, the whole thing times with V. If I want to use V2, then the equation will be V2 equals to R2 over R1 plus R2, then the whole thing times with V. So generally, the difference is, if this is 1, this is R1. If this V2, then this is R2. So this equation is important, okay, in the sense that for you to calculate, you see 3 marks. So formula itself, you already get 1 marks. So whichever formula you can apply one. Okay, so assuming teacher using the first formula, so now teacher erase all this, okay, you will still get the same answer one, or whether you use this or the one. Okay, so this one I shift up a bit, okay, so basically they want you to find what? RQ. RQ is actually referred to R2 lah. And then they give you V2, you know, your V2 is 4. Okay, so if V2 is 4, what is your V1? Your total is 6. That means your V1 is basically 2. Well, so far so good. Okay, so now let's sub everything inside. So we will have 2 equals to R1, which is 20 ohm, 20 kilo ohm. So I write 20,000. Then over R1 plus R2, which is 20,000 plus unknown. R2, R2 is the unknown. And then the whole thing times with total voltage, which is 6. Okay, R2 times 6. So those of you who are not good in maths, I will say the bottom one, you bring it up, then it's multiply already. So 2 times 20,000, you have what? 40,000 plus 2R2 equals to 6 times 20,000. So you have 120,000. Then 2R2 will be 80,000. So hence R2 will be what? 40,000 ohm. So this R2 is referred to RQ lah. Okay, R2 equals to RQ if you want to be alert. Now you can sub the idea as RQ1 actually if you want to, okay? It's just that because teacher want to introduce your general equation, or how do you get this equation? Okay, so the answer scheme given is like this, so it's same thing one, like how teacher explained, okay? But they use VQ over RQ equals to V over RQ plus R2 lah. But the idea is same one. So generally your RQ is still get 40,000 ohm. Okay, so teacher hope that you all know how to use the potential divider formula already lah. Okay, so proceed. Number 3. Diagram 3 shows the moon orbiting the Earth, while the Earth orbits the Sun, and the gravitational force between the Sun, Earth, and Moon can be determined by using the Newton universal law of gravitation. So firstly, what is Newton universal law of gravitation? So in short, they actually have a equation or relationship under this Newton universal law of gravitation, where they say the gravitational force is actually directly proportional to what? The mass of the two bodies. And then it's actually inversely proportional to the distance square for the object, right? From the center of between these two objects. We call this R lah. So therefore, okay, in sentences wise, you make it into the sentences wise. So gravitational force between two bodies is what? Directly proportional to the product of the masses of both bodies, and inversely proportional to the square of the distance between the center of the two bodies. Okay, now so this is how we have this, and from here, after we combine, then we can change the idea to equation, or whenever we change the directly proportional sign to equal sign, we follow by the constant. So in this context, the constant is capital G, which is what we call a gravitational constant G M1 M2 over R squared. Okay, so they say compare the force between Earth and Moon, Earth and Sun. So the big difference between Moon and Sun is generally what? Is the idea or the context of what? Mass, right? Okay, so which one have greater mass? The Sun. So if the Sun have the greater mass, that means your force will be higher as well compared to the Moon. Okay, so firstly, you tell the relationship. So gravitational force between Earth and Moon is less than gravitational force between Earth and Sun. Why? You can say the mass of Moon is less than Sun, or vice versa, you say the mass of the Sun is greater than the mass of the Moon. Okay, so this is the idea on this from 4 topic, okay, gravitation. Okay, then move on, C. C, they want you to calculate the height of the Moon from the Earth surface H, and given, they give you what? The mass of Moon, mass of the Earth, the radius of the Earth, and then the gravitational force between Earth and the Moon is 2 times 10 power of 20. And they give you the gravitation constant as well. So the formula that we're going to apply here is actually what? F equals to G, okay, capital M, small m. Sometimes we use capital M, small m. Sometimes we use M1, M2. Doesn't matter what. So we can just assumption of capital M is Earth, then Moon is small m. Okay, then radius of Earth, indeed it is capital R, the symbol. So this is force, and then this is G. Okay, but they want height. Okay, so first idea, you need to know that what is this small r refer to. So just now, based on the equation teacher already mentioned, right? This r is basically the distance between the center of the Earth or to the center of the Moon. Okay, so therefore, you need to, what is this R? R is actually including the radius of Earth as well. Okay, I shift this arrow, make it easy for you to see. Okay, so basically, R is not until the center only, until the center. So the center part here, that means this part is capital R. So R is actually H plus capital R. Okay, now they want this H lah. Okay, so it is easier that you find out this small r first, the distance. Then only you use you want to find height, right? Height, hence it will be what? Small r minus the radius of Earth lor. So we find out this first. Okay, so I normally tell students rearrange the equation so that your subject is what you want to find on the left hand side. So we interchange the position, understand? Okay, you have G capital M small m over F. Now you sub log G value 6.67 times 10 power negative 11. Then the mass of Earth 5.97 times 10 power of 24. Small m 7.35 times 10 power of 22. Then the whole thing divided by bracket. Whenever you press calculator, right? So the force here is 2.00 times 10 power 20. Okay, you find out what is R square first, or slowly by slowly. Okay, so when you get R square, right, you don't round off too much yet. Okay, you can leave it many decimal point, especially during substitution. So end up, I will have R by R, I square root the whole thing. After I square root the whole thing, I actually get 3825. 4167 4.2 meter. But I don't want R, I want what? H. So how do I get H? So H is basically 3825 4167 4.2 minus the capital R, which is this one. Okay, 6.37 times 10 power of 6. Then finally get the answer lah. Now, it's advisable that all of you all try to press calculator. I will say, you all listen, no point one. You all have to do it there and there. Okay, which means you have calculator, you do it now. Because sometimes you know the formula, but then you can't really get the answer. It's because you do not know how to press your calculator or you didn't practice well. I always say chapter 3 generally is not hard, but a lot of times students cannot score is because when they insert the value lah, the power wrong lah, got negative, forgot to put negative lah, got square root, forgot to square root lah. So all this is the thing that because you all lack of practice ah. So that's why whenever you all do this chapter, right, memang it's a bit time consuming, but just do as much as you can. Okay, now and if any of you want to write in standard form, it will be 3.7617 times 10 power 8 meter. Same thing, do not round off too much, minimum 4 decimal point. Okay, because you round off a lot, then it's considered wrong. So let's say any of you write 3.76 times 10 power 8, right? Oh, sorry. Your final answer, no marks. Why? 2 decimal point. They want minimum 3. It's good that you stick to 4 lah. I always tell students, if whenever you confuse about decimal point, you stick to 4. Okay, so this is from the answer scheme. So they actually sub together. Also can this way, no problem. If your maths is good, then it shouldn't be a problem for you. Okay, but I see a lot of students always make mistake, This one, if you want to expand it, it's not like that. Sometimes the student blah, they go and write like that. I tell you lah, okay, the idea that student will mix wrong. So this is not the correct concept for maths. Okay, so that's why just now whatever I ask you to do is much more easier and not so confusing one. So you use this technique, it's better. Okay, then now we have questions 4. Question 4, okay, diagram 4 shows part of the uranium-238 decay series. So firstly, what is mean by radioactive decay? So generally, radioactive decay is a process where unstable nucleus become more stable by emitting radioactive radiation. So the radioactive radiation here refer to what? The alpha particle, beta particle, or even gamma ray. Okay, so this is the idea lah. Okay, next, based on this diagram above, determine the number of alpha particle and beta particle emitted when uranium decay into radium, okay, 226. Okay, so for your information, you want to understand this topic well, you need to know what is so-called alpha particle. So alpha particle is actually the helium nucleus, okay? Then beta particle is actually electrons, 0, -1. So you look at the neutron number. So if it is emitting the alpha particle, right, they will reduce by 4, 1. But then if they are emitting beta particle, there will be no change in the nuclear number, understand? Because 0, but their proton number will increase by 1. Whereas alpha particle, they will reduce by 2. So you see, 238 become 234. That's mean reduce by 4, right? 92 become 90. So reduce 4, 2. That's mean this is alpha. Okay? But then you see this one, 234, 234, no change, right? But what happened to your proton number increased by 1? So that's mean they are emitting beta. Okay, right? Then you see this 234, 234, no change. It's again on beta. 234 become 230, 92 become 90. That means this is alpha again. Then 230 become 226. Again, this is alpha. So lastly, the number of alpha based on what teacher write on top. How many of it are? 1, 2, 3. Whereas beta, you have 2. Okay, now, what happened to the number of alpha particles emitted in 4p if the surrounding temperature is reduced to near freezing? Okay, so for your information, this radioactivity, right, they are not influenced by temperatures or pressure. So generally, there will be no change in the value. Okay, there is no change in the value. Okay, so we will proceed to the next part. Okay, on these questions. Okay, so giving you have this decay equations. They already told you it's going to emit alpha particle when radium change to radon. So calculate the mass defect. Okay, so you can generally write out the equation, also easier for you to capture the idea. Okay, so generally Ra 226 88, they will become radon 22286 by emitting what? Alpha. Alpha is He for 2. Okay. So the idea behind is this is called parent nuclide. Parent, then this one is daughter. So, or I always tell students, you'll notice that the mass before, right, the decay and after, there'll be difference one. Before is always more than after. So the difference between the mass is basically the mass defect. The mass defect. So how do you calculate the mass defect? Memang you use 226.54 minus the sum of 222.018 plus 4.003. Because it's 1 mark, you can straight away show the answer. Okay, so you have this 0.519. Then part 2, how do you calculate the energy release? You are using the E equals to mc square idea. But the mass in atomic mass unit, right, you have to change to kg. So same thing, normally they will tell you in the equation, or how do you change AMU to kilogram? Is by time 1.66 lah. Okay, or time 10 power negative 27. Okay, so that's why they straight away use this equation E equals to mc square. So the mass you time with this first, then it's in kg. Okay, then you can sub the value straight away here lah. And be careful, C must square it, square it. Okay, then finally your final answer is this one. Okay, I don't want you all to write 2 decimal point, a bit risky nowadays. So that's why it's good that you all really, again, like I say lah, you try to press the calculator. I try to see is there any mistake on the questions first? So 226.54 minus. Okay, then time 1.66 times exponent negative 27. Okay, then time 3 times exponent 8. Bracket square it. Yeah, okay. So the answer is correct lah. Okay, then your unit for energy can be in joule lah. Okay, next, if the mass defect decreases, what happened to the energy? So based on E equals to mc squared, if this mass defect is less, that's why your energy also supposed to be decreasing lah. Okay, next, question 5 and 6, they are actually comparison questions. So diagram 5.1 and 5.2 show the brightness of bulb W and bulb Z, when current I flow in them. So firstly, what is meant by current? Now you can use sentences to define current, or you can use formula in deep, okay? But not all formula can use for definitions. So for this context, current is rate of flow of charge. Okay, or you can actually write like that, current equals to charge per unit time. Write in a formula way, exactly. Exactly. In short, I equals to QOT, but you cannot write simple only. Okay, so either way is correct. Okay, next, compare the voltage across the bulb. Okay, so from the reading of voltmeter, voltage is from what? Voltmeter. So if you don't really like this chapter, not much idea, but you know which one is voltmeter, right? You can compare already. So 5.1 is greater. Number of turns. So which one have actually more turns? More coil. So same thing, all 5.1 also. Then which one have high resistance? So the factor affecting resistance, when more turn means more length. Okay, so when longer length, there will higher resistance. So same thing, everything will be 5.1. And the film bulb, they function because of what? The resistance is high, and then they produce more heat. So the more heat that's mean the brighter the bulb is. Okay, so again, everything is for 5.1. So this is the way how you write it. Voltage across bulb W is greater. Okay, or in 5.1 is greater. You can use the term 5.1 here. They will use bulb Y and W and Z lah. And then number of turn, bulb W is more. Resistance W is more. Okay, and hence brightness also more. Now, do not do this kind of thing. I know that some student comparison question, right? They just totally ignore everything like that. They just say W more than Z. W more than Z. It's not advisable to do that, okay? Because seems like not complete as questions, especially in essay. You need to write full sentences. So I will say SPM only one time, please write full answer. Okay, lastly, the relationship. So in relationship idea, indeed, if there are increase idea, you can use directly proportional. Increase decrease is inversely proportional. But again, you always confuse the safer way. You use hypothesis way. Okay, where you say number of turn increases, therefore resistance increases. Then the resistance of filament wire increases, brightness increases. So this is the best way lah. Then proceed D. D is on calculations now. They give you what? The length, the diameter, the resistivity, and then they want to calculate resistance. So basically, you all have one formula that can relate resistance with the resistivity one. Okay, it comes from the topic under factor affecting resistance on this 3.2 idea. Okay, so the idea or the concept behind is like this. Resistance generate directly proportional to the length. Okay, and this resistance also inversely proportional to the cross-sectional area. Okay, so when we combine this, we have length then over A. So every time when you want to change this symbol to equal sign, they will follow by a constant. Phi. This constant is called phi. This constant is actually resistivity. Then you have phi L over A. So once you know the formula, then it will be easier for you to calculate. If you do not know the formula, you cannot calculate, right? So memang they are going to find R. So my R is subject. Now phi is given. The unit SI is ohm meter. So no problem. So I can just put inside straight away. Now next, length. Do they give me length? Yes, this is length. Okay, which is times 2 meter. Okay, now it's the idea of a surface area given now. No, right? They give you diameter, but how do you relate the diameter with area? So the wire is a cylindrical shape, so the area is actually a circle. So what is the area of circle? So you need to find the area aside first, then only sub inside, or you can straight away put inside lah, but easier for you to capture. So area is pi r square, right? But they did not give me pi r, so that give me d. So d divided by 2 square. So you can find aside first, or indeed you can put everything inside. But sometimes too many numbers inside, some people press calculator, confuse again. So my advice, you find out A aside first. So the diameter memang is in meter, so they're not confusing you with the unit idea. So you find out this value first. The pi, you all can use a calculator pi, or you can use 3.142 or 22/7. It's not a big problem lah. Okay. So let's try to get the answer first. So I generally get the surface area 7.06858 and 10 power of -8 the square lah. Then I put inside. So same thing, when you press calculator, right? Always make a habit, bracket it. Okay, so finally, I actually get 1.584475. 58445. You round off to 4 decimal point, then you get this stuff. Yeah. Then the unit is ohm long, memang resistance is ohm. So I hope that you all know how to apply the formula of for resistivity and resistance. Yeah, so this is the answer scheme idea lah. That straight away sub everything inside. So it's okay if you good in maths, you can actually do like that, but still show the substitution for everything. Okay, because sometimes the students straight away give the final answer without showing substitution. So you may get 0 marks if you do so. Okay, then the next comparison questions, question 6. Diagram 6 show a graph of maximum kinetic energy against frequency for matter P and matter Q. So this is under quantum physics, the last subtopic. So the threshold frequency F0 and the work function for each matter can be determined by the x-intercept and y-intercept of the graph of Kmax against F respectively. So firstly, what is the meaning of threshold frequency? So for your understanding, threshold frequency is actually the minimum frequency needed for the photon energy, right, to cause photoelectric effect. Okay, yeah, so this is the definition, minimum frequency that can produce a photoelectric effect on metals. Okay, then given that the Planck constant is 6.63 times 10 power negative 34 joule second, calculate the work function. So for your understanding, work function and threshold frequency have a directly proportional relationship, okay? And the equation that we can use for calculation is work function W is equals to HF naught. So you have the F naught on the previous page, which is 6.64, right? Okay, times 10 power of 14. Okay, hence you can calculate it, just sub inside. Okay, wait, sorry, the one for Q, so just now teacher mentioned 6.64, wrong, it's for Q, so it's 10.34. And then you all be careful, they always have this 10 power 14 or anything joule or times 10 power 20, all this you need to include one. Okay, so I tell you already where the 1014 come from is here. Then you get your answer. The work function is generally 6.85542 times 10 power negative 19 joule. C is a comparison part. So firstly, they want you to find compare the threshold frequency. So this is actually F naught threshold frequency, but this one is for P, this one is for Q. So obviously, which one is greater? The Q one is greater. Now, then this is work function. Okay, so same thing, Q will be high here. And what about the energy, maximum energy emitted from the metal surface? Okay, so we see the answer first. Threshold frequency of P is less than Q, or vice versa. You say Q more than P. And work function P also less. Okay, whereas the maximum kinetic energy from metal P is more than Q. So how we get this idea is actually from Einstein equation of photon energy equals to what? Work function plus K max. So the photon energy is constant one, agree? Okay, then when your work function is greater, that means your K max will be lower. Or vice versa lah. If your work function is lower, your K max will be greater lah. Then what is the relationship between threshold frequency and work function? When threshold frequency increases, work function also increases. And then part two, the work function to the maximum kinetic energy, they will be inversely proportional idea. So when work function increases, the maximum kinetic energy of photoelectron decreases. Okay, E. What happened to the electron on the surface of P, metal P, if a beam of light that has frequency 6.64 times 10 power 14 is directed? So they already show up this value is exactly the threshold frequency. If they are same, that means generally the photoelectron already emitted up. They already emitted up. It's just that their Kmax is 0. Or you can say E equals to work function, that's it, finish. Okay. But photoelectric effect already occur. Photoelectric effect already occurs. So this is the understanding that you all should have. Okay, so that's why this is how you answer the questions. The photoelectric occur where photoelectrons are emitted. It's just that they do not gain kinetic energy, only the Kmax only. But if they say light frequency with 6 times 10 power 14, 6 less than 6.64, right? This means no photoelectric effect occurs. Or any value that more than 6.64, then photoelectric effect occurs. So I hope that you all can have a better understanding regarding the concept of this Einstein theory for photoelectric effect. Okay, so for question 7, diagram 7 shows hydrofoil attached to the bottom of a boat, and the production of the lift force by the hydrofoils is based on Bernoulli principle. So this is actually under Form 5, Chapter 2 pressure on the Bernoulli principle. So what is Bernoulli principle? So Bernoulli principle involves two important physical quantity, which is the idea of velocity and also pressure. So what is the definitions? So when the velocity of fluid increases, the pressure in the fluid will decreases, or vice versa. So fluid can be referred to gas or liquid. So the hydrofoil idea is actually similar like the aerofoil, but hydrofoil is in the water. Okay, so part B. The surface area of the lower part of the hydrofoil in diagram 7 is 0.5 meters square, and the pressure difference that exists between the upper and lower surface of the hydrofoil is 50 kilopascal. Calculate the lift force produced by the hydrofoil in the unit of Newton. Okay, so how do we solve the questions? We can actually have this idea of, first, you're going to be alert of the kilo. Kilo is 10 power 3. Okay, so the formula that we use is pressure is force per unit area. So the lift force is actually pressure times with the surface area. So the pressure, like you just say, you have changed to 50,000. All this enable you to get 1 mark. And then you sub into this equation, 50,000 times 0.5. This is already in SI unit. So finally, we have 25,000 and must write the unit Newton. So you get 3 marks for this questions. Okay, then C. Okay, C is a part that's similar like section B essay questions, but their characteristic is less compared to the essay one. So they show what the hydrofoil surfboard of ST and U use in the surfboard competitions. So based on the table, state the characteristic of the surfboard that can move the fastest. So size of the hydrofoil, should it be bigger or smaller? Okay, and then the power of the motor. So of course, in the power context, we want it to be high power lah, right? Then next, should it be big or small? So generally, a larger surface is better because just now we do the calculations. Notice or not, the lift force is pressure times surface area. So if your area is bigger, automatically your force will be greater as well. So that's why we will prefer it to be a bigger surface area, okay, whereby produce more lift, and then the power wise, okay, you can produce more forward thrust or higher acceleration. So finally, we will choose U lah. So this type of question, same thing. If you choose correctly, you already get 3 marks out of 5 marks. Or similarly, if you choose wrongly, then a bit sad lah. Maximum, mostly you can get 2 marks long. Okay, then questions 8. Question 8 is on Form 4 topic, total internal reflections. A man see a bird on a tall tree using binoculars. Diagram 8 shows the structure in part of the binocular. So state one characteristic of the image of the bird that can be seen using binoculars. So the characteristic generally is supposed to be upright and then virtual. And in this context, with the help of lens as well, because you see, when we talk about binocular, it's the whole thing. Without the lens, generally they're supposed to be same size. Okay, so but this case now, you have the lens, so that's why indirectly we actually magnify the idea. Okay, so this is a characteristic lah. You write one of it. Okay, either upright, virtual, or magnify. Okay, then next on diagram 8, complete the path of light ray that entering the binoculars. Okay, so how do you complete the path? So basically, when the rays strike into the lens, they will just go straight off. Then because they are on normalized, so they'll just enter the prism. So for your information, whenever you draw the diagram, you should have normal line. So this is the normal line. So generally, the critical angle for prism is about 42 degrees. And this angle generally is always 45, which is greater than the critical angle. So that's why the ray will actually straight go down here. And upon this point, again, they encounter second time of total internal reflection. Then go down again. Then only enter your eyes. So this is the path lah. Okay, and then you complete with the arrow. Yeah. Okay, from answer scheme, this is how you show the idea lah. So they actually encounter 1 time, 2 time, 3 time, and 4 time total internal reflections. Okay, C. You're required to suggest modification that can be made to the binocular so that the image seen is closer, is clearer and easier to carry when looking at birds that are far away on the tree. State and explain your modifications based on following aspect. So it's similar like section CSA questions. So focal length of objective lens. So for your information, when the focal length of an object is long, right, your image is further magnified one. Okay, so that's why we need to have long focal length, higher linear magnification. Then diameter. So diameter of lens refer to this. So this is small diameter. Then this one is called big diameter. So we want more light to pass through. All right. So bigger is better. So you will have brighter image for the end result. Okay. More light enter. Then body of the binocular. So you can say low density material, strong material, or you can describe if you do not know the actual name, or it's actually carbon fiber. Okay, if you write carbon fiber, then you can write strong lah. If you write strong, then not easy break. You cannot say strong, then you only get 1 marks. Okay. So this is how we do the questions for questions 8. Now we will proceed to essay questions. So questions 9 is actually the essay under the Form 5 Chapter 1, 1.4 elasticity. So diagram 9 show an archers pull the bowstring with a force F resulting in extension of x cm. So when the arrow is released, it will travel at a speed due to the elasticity of the bow. So firstly, what is the meaning of elasticity? So elasticity is generally what? Okay, the property of the material that enable it to return to its original shape or size after the force acting on it is being removed. Okay, the idea force being removed is important. Now you need to use this idea one, and then only they're able to go back to its original shape and size. Okay, then using the concept of elasticity and principle of conservation of energy, explain how archers can produce a far shooting distance. So conservation energy, so you need to know the type of energy that involved. Okay, so the example of energy that you're supposed to know is what? You have kinetic energy, okay, elastic potential energy, gravitational potential energy. So in this context, the energy that's stored in any elastic object is called elastic potential energy. So you need to mention this, okay, and then generally it will end up convert it to become kinetic energy. That's why the arrow can move further. So firstly, when you say the bowstring pull, right, what energy is being stored? Elastic potential energy stored in the bow. Okay, then when you release it, okay, the bow will back to its original shape and size based on elasticity idea. Then the energy transferred to the arrow become kinetic energy. So the further the bowstring is pulled, the greater the tension. And then the more energy stored, the higher the energy of kinetic energy that cause the arrow to move further. So this is how you gain. Okay, generally it's supposed to be 4 marks question, this kind of questions. Okay, then C. The force applied by the archers is 100 Newton and the extension is 50 cm. Calculate the spring constant. So what is the formula for spring constant? Okay, so we have F equals to Kx, where K is spring constant. So we have K equals to F over X. So you have the idea of F, you have the idea of X. Now, if you directly sub, then you careful with the unit. So let's say you directly sub, so the unit is Newton and cm. So you can have Newton per cm, but then cm generally is not SI in it. So any of the student change this cm to meter, you can also have your unit as Newton per meter later on. Okay, so now teacher show you all the answer first. Okay, so either one is actually correct. This one, if you do not convert the 50 cm. So you're supposed to have 2 Newton per cm, but you change 50 cm to become what? 0.5 5 meter. Then your unit is Newton per meter. So it's important for you all to write unit. That's why sometimes you all leave your answer 2. That is wrong. You only get 1 substitution marks. Then for part 2, they want you to calculate elastic potential energy. So the formula for elastic potential energy is actually half Fx or half Kx squared if you were to have K. So either formula can be used now because you have K, or you can directly use this one. But generally, when you give unit for energy, what is the unit for energy? Joule, right? So it's advisable student change the X to become what? To become a meter. Therefore, you have 25 joule. Notice or not? That's why changing to SI unit sometimes enable you to get 1 marks. Okay, there. The question memo requests you all to give the answer in joule. Okay, then proceed D. Give 1 reason why a bowl will not return to its original condition when extend to the certain length. So you see when you stretch too much, okay, the bowstring already lose its elasticity, which means that exceed the elastic limit lah. So this is the answer that you can give. Okay, then next one is a 10 marks questions. So section B, you memang have 2 questions or to choose 1. So same thing, try to read through both questions and decide which one to use. So table 9 shows the bow P, Q, R, and S, which is used in archery sport. Okay, study each of the bows of these bows and explain the suitability of each features and determine the most suitable bow to produce the longest shooting distance. Now, whenever you all go through the questions, right, I always tell students do highlight the statements as well. Their purpose is what? Longest shooting distance and easy to carry. So you stick in your brain, later on the reason for all this aspect, you cannot say easy to carry or produce longer shooting distance because already in the question. So you cannot use this as answer. You cannot use this as answer. Okay, so let's go through which is the best idea one. So material of the bowstring, should it be elastic or less elastic? So generally should be elastic, right? So the last one already not right. Then you want the bow to be heavier, so lighter is better, correct? Actually, you already get the answer. So do you have the arrow fletcher feathers of arrow fletcher means this is arrow. So normally they attach this is the feathers. So we need to have. So the function of this feathers basically to make it more stable. And lastly, the material carbon aluminum is actually better than plastic lah. Yeah, so we choose S. So like teacher say, the moment you choose correctly, you can get 6 out of 10 marks with the correct way of answering it lah. So you should construct a table. Then left hand side, you write the characteristic for this S, everything for S. Understand? Stiff and elastic. Why? So you can store more elastic potential energy and then change to higher kinetic energy. Then mass of bow low. You don't write 2 kg. Understand? Don't write number. Only describe. Because if I were to have the bow which is 1.5 kg, is this better? 1 kg, is this better? Yes. So that's why we just describe low. Why lighter? Can you write easy to carry? Cannot because it's in the statement. Then arrow fletcher feathers have one, the arrow movement is more stable. But like teacher said, increase the stability. Then the material carbon aluminum strong or light. Okay. Now you can give more reason one. Can give more reason. Okay. Then finally you say I choose S because the bowstring is stiff and elastic. Then the mass is low, have arrow fletchers feather, and lastly the arrow is made by carbon aluminum. So you give back all the characteristics. So 1, 2, 3, 4, 5, 6 is what I said without reason. Plus 4 reason, 10 marks. Okay, now we proceed to the next essay question. So question 10 is the essay question from 5 topic chapter 4 electromagnetism under the idea of electromagnetic induction. Okay, we go through the questions right now. So diagram 10.1 show a smartphone being charged using the wireless charger. and there are coils inside the wireless charger and smartphone that allow the wireless charging process to occur based on electromagnetic induction. So smartphone can be charged by wireless when the back of the smartphone is placed on the wireless charger. So firstly, what is the meaning of electromagnetic induction? So the idea is we want to induce electromotive force or induce current. So how do we do that? We need to have the rate of cutting. We need to have change in magnetic flux. So generally, with electromagnetic induction, the production of induced EMF in a conductor when there is a relative motion between the conductor and the magnetic field, or when the conductor is in a changing magnetic field, okay? So this is how you give the first statement of production, induced EMF when relative motion between the conductor and magnetic field, finish. Or when the conductor is in a changing magnetic field, or cutting of magnetic field also can. Now, how the coil in the wireless charger can charge the smartphone. So for your understanding, you have it's similar like what you all learned in transformer. So in transformer, you have this left side at primary, but you actually supplying the this AC supply, agree? Then the secondary is on here, then you connect to any device, bulb like that. So the primary coil is in the wireless charger inside the heat. And those smartphones, they must have the secondary coil, they also have coil. So the idea look more or less similar like transformer. So transformer, when you supply alternating current, they will produce field. Then this field cut the coil, right? Then later on, AC, they will collapse. Okay, then they will appear. Then they will collapse again. So same idea, lor. So this one is the idea whereby you also will have this similar idea. So you produce the field or from here, okay? Then you linkage to the secondary coil. Then same thing, okay? They will collapse. Then there is a constantly changing of magnetic field. So that's why the EMF is induced in the smartphone. So this is how you write. Wireless charger is connected to what supply? AC supply. Then alternating current flow through the primary coil, very magnetic field is produced. So when smartphone is placed near the wireless charger, there is a cut of magnetic flux, rate of changing of magnetic flux occurs. Then induced EMF is produced in the secondary coil. And generally, our phone need direct current. So that's why you need to add a diode, okay? So you say induced EMF produce, induced current also produce. Then generally, you need to change or convert this AC current into direct current. So this is how it works. Okay, then B, table 10 shows the choice of compartment that can be used to build the prototype of wireless charger. So based on table 10, identify and explain the suitability of each component to produce wireless charger prototype that have high efficiency, and then determine which prototype is most suitable to be used and give reason for your choice. Okay, so same thing, you all need to choose. Okay, so what happened to the number of turn of primary coil? Should it be more or less? And then what is the wire? So you should have a good conductor or bad electrical conductor. You want good one, right? So which is better, nickel or copper, because they have low resistance. So you see this context, you already bye-bye. And then next one, you want to have a thick wireless charger or thin. So we want to be thin because it's just like the idea, if it's thicker, then your coil is further from secondary coil, understand? When it's thin, when you place your phone on top of the charger, the distance is lesser because thinner. If it's thick, then it's the coil will be further apart. It's actually related to the plug linkage idea. And of course, the supply should be AC one. Get the idea? So DC memang is out already one. So based on the choice that teacher show you right now, obviously you will choose S. Sometimes you do not know whether the expect first one, second, you don't need to start from 1, 1. You can start from 4, 3, 2, 1. Whichever expect that you are more confident with. Okay. So primary coil generally you need to be more. Why? So your strength of magnetic field increase, or the chain of flux as well is increased. Hence produce more induced current. Copper, like teachers say, low resistance, low resistivity also can. Then you have more current. Wireless charger thin, okay, distance between the primary coil and secondary coil is short or reduced flux leakage. And lastly, alternating current, okay, so that you can have changing of magnetic flux, or the rate of change of magnetic flux occur at secondary coil. So therefore, again, our choice as is chosen as is at many number of turn of coil in primary coil, and then the type of coil is copper. The thickness of wireless charger is thin, and lastly we use alternating current. Okay, then lastly we have the calculation part. So the calculation part is under transformer, very direct. Okay, so let's say the transformer have the wireless charger plugs. Okay, assuming the transformer is ideal, keywords are ideal. So firstly, they want you to calculate the number of turns of primary coil. So the primary coil idea will always relate with the primary voltage Vp, Vs, and then MPSS. Also generally MP over NS equals to Vp over Vs. Then we have all this so you can find the number of turns lah. Okay. They are using the idea of Vs over Vp equals to NS over MP. But like I say, if you not put in maths, you put primary on top lah. So you no need to pindah so many things. So you see, if I use MP per NS, Vp per Vs, right? So I want MP So Vp is what? 240 over 6 times and S 70. So you're supposed to get the same answer as well. I pindah for you. Memang no unit, no unit. Okay, number of turns Next, how do you get the current in primary circuit? So for your information, since the transformer is ideal, if it is ideal, the output power must be equals to input power. So output, the formula for power is Vi as well. So output is everything secondary, input is everything primary. So they want the IP idea. Do you have Vp? Yes or now, do you have VSIS? You only have VS, you do not have IS, but we don't need this. We can have the power straight away, the output power. So that's why we have 50 equals to 240 IP lor. So IP equals to 50 divided by 240. And then you will have 0.208333. They actually find out the current first, but not necessary. Okay, that's why there is a slight difference. Just now teacher use the idea one. I say my answer is what? 0.8333, but they are quite close quite close. So no problem, you can use this also, the same thing. Okay, last question, section C essay questions, open-ended questions. Is under Form 4 topic, specific heat capacity. So diagram 11.1 and 11.2 show the phenomenon of sea breeze and land breeze that occur due to the difference in the specific capacity of seawater and land. Okay, so firstly, what is the meaning of specific heat capacity? So what is specific capacity? Specific capacity is the heat needed to increase the temperature of 1 kg of substance by 1 degree Celsius. Okay, very short already, this one. But all the keyword is that heat, temperature of 1 kg and 1 degree Celsius. So without or you use the wrong terms, then tak dapat markah. Okay, then move on. Based on both diagram, compare the specific heat capacity of land and also seawater, then temperature above the land, the density of air above land, and also the direction of air flow. Okay, so in terms of specific capacity, they also tell you the land and sea are 3,900 and also 1,632 respectively. So the specific capacity of land is actually lower. I think there is a slight mistake because they terbalik already. Okay, terbalik a slight mistake here lah. Memang seawater, the specific capacity is higher. That means seawater is this one lah. Then is this one. Okay, so for your information they got errata. Okay, so that's why specific capacity for land is less, and the air temperature above land is a higher temperature lah, greater. You can use smaller or greater, or because sometimes you do not know how to describe temperature actually you can use the word high or low lah. And then air density above the land is lower. Or you're not sure, you use this smaller sign. So in diagram 11.1, the direction of the airflow is from the land to from the sea to the land, whereas this one is from the land to the sea. Then what is the relationship when specific capacity increases, air temperature decreases? Okay, and the temperature of the air above the land increases, then the direction of airflow is from sea to land. That's why you call it as sea breeze. Wait, let me check. Yes, okay. So you're careful about the relationship, can counter check don't confuse yourself or tembak because this is like compulsory game marks in your questions. Okay, then diagram 11.3 show beach chair placed on the beach during daytime. The beach chair feel hot when you start sitting on it, but after some time you don't feel as hot. Why? Explain. Okay, so this beach chair is actually you feel hot initially is the temperature is higher than you so you actually need to relate this idea with a thermal equilibrium concept or thermal equilibrium concept. So generally you say heat flow from high temperature to low temperature, which is our body lah. Then until they reach the same temperature, or when they reach thermal equilibrium, okay, the net flow of heat is 0. So that's why you feel no longer hot because the temperature is more or less the same right now. Okay, last question is modifications questions. You need to find the expect to be modified lah. So diagram 11.4 show a grill that use charcoal to grill food by the beach. Okay, you are required to suggest some modification that can be made to the grill in this diagram 11.4 so that the grill can be held securely and it is portable and able to grill large amount of food quickly without the disturbance of the wind from the shore. State your recommendations based on the features of the grill net, grill body, grill size, and additional tools on the grill, and give reason for your answer. Okay, so they already tell you what to be modified. You see, grill net, body, size, additional. So at least here got 3 and then here 4. So here you can split. So sometimes you can talk more regarding the grill net, grill body, or size memang satu sahaja lah. So all this is how you can get more than 5 aspect. Okay, memang minimum you need 5 aspect, 5 reason. Then only you can get 10 marks. But some people who good, you can give more aspect, more reason. So depending, as long as your answer is not contradict. Okay, example, you talk about the grill body, okay? You want it to heat up faster or slower, all these so you cannot like give 2 opposite answer at the same time. You say the grill body is high specific capacity, and later on you say you low, then tak boleh lor. This kind of answer is not acceptable. Then additional tools, okay, you can add on so you can add a lid example, cover it so you trap heat so you just give the idea. If the answer is not related, they're not supposed to minus you mark lah. Okay, let's see the answer. So generally, glue net have to be good heat conductor because you want to heat up faster. Agree? or low specific capacity. So actually you can split into two boxes, or you can say like that, the drill net is half. But need to write the drill net, the terms are, you cannot just suddenly say low specific capacity. So it's referred to the body girl net. So that's why nowadays it's good that you copy back and then you put dot dot like that. Okay, then drill body coated with porcelain, or they are good heat insulator, so has specific capacity. And then drill body low density lighter. Then drill size big lah, so you can cook more food at one time, or use shorter time. So you can add fan, so you can supply more oxygen. So the rate of burning is higher. You add lead track the heat, or you have additional tools like mills, so you can move the drill from one place to another place easily. So this is the idea lah on this concept. Okay, so this kind of question, if you are a good student, teacher always encourage one. Just try to give more expect, as long as the answer is not contradict. Then no problem, but you can give as many as you can. So of course the maximum is 10 marks lah. Yeah, so teacher hope that again you learn something for this state paper, right? And we will see again on the next state paper. Okay, bye bye everyone.